Good day, everyone. So we are reviewing Wetzel's Limnology textbook, the edition number 4, chapter 4, which focuses on lakes and rivers and their formation. And we are on the sixth installment of that chapter, and we are about to embark into subsection B of lakes formed by tectonic activity. But before we do so, let's review figure 4-19. 4-15, sorry, which is origin of a tectonic lake due to crustal tension and extension. A depressed fault block, a graben, which is right here, occurs between two higher fault blocks, horst, which are right here. While erosion and deposition can fill in some of the graben valley, large and deep tectonic lakes may eventually fill the depression. So the evolution of a tectonic lake is, first you have just the usual continental crust here with some tension cracks, and you have a force that is exerted on this block that is away from the block. So we have this force right here on the left and on the right, and that extension is then creating this this deepening of the graben, where the graben basically kind of like decrease in altitude and lowers. And the graben is then wedged between two horst. And ultimately what happened is that there is a closed basin lake that is formed within that graben. So there's no way for that water to escape and into an ocean or a sea. And then on the sides of the horst and the graben, you have slope deposits and alluvial fan, while the extension still occurs. So what are some of the examples of these types of lakes? So one of them is Pyramid Lake, for example, in Nevada. It's a closed basin lake that is a graben-based lake, or an endorheic lake. Okay. So lakes formed by tectonic activity. Tectonic lakes occurs in depressions formed by movements of deeper portions of the Earth's crust and are differentiated from lakes that resulted from volcanic activity. The main type of tectonic lakes forms as a result of faulting, in which depressions occur between the bases of a single fault displacement or in downfaulted troughs. The later type of depression is referred to as a graben, and multiple grabens can form a rift valley. Lakes formed by this mode of origin are called grabens or rift lakes, and include most of the world's relict lakes, referring to their nature as being remnants of pre-existing formations. Arguably, the most spectacular among these is Lake Baikal, the deepest and oldest lake in the world, which has a continuous lacustrine history from at least the early tertiary, which is between 25 and 30 million years ago. Lake Baikal and many other relict lakes are of particular interest because they contain a large number of relict endemic species. For example, of 2,595 aquatic animal species and subspecies found in Lake Baikal, over 56% are endemic to this lake, meaning by that they are native to the lake. Lake Tanganyika of equatorial Africa is a similar deep graben lake, maximum depth of about 1,435 meters, formed in Rift Valley displacements along crustal fractures and contains many relict endemic species of plants and animals. The Dead Sea of the Middle East represents a unique hypersaline graben lake with its surface at 430 meters below sea level. Tectonic movements causing moderate uplifting of the marine seabed have isolated several very large lakes. The relict marine depression of Eastern Europe, which includes the Caspian Sea and the Aral Sea, were separated by the formation of uplifted mountain ranges in the Miocene period. Similarly, the somewhat more localized upwarping of the Earth's crust in lesser degrees also has resulted in the formation of many large lake systems. Lake Okeechobee in Florida resulted from minor depressions, maximum depth of about 4 meters, in the seafloor as it uplifted in the Pliocene epoch to form the Floridian Peninsula, and it forms one of the largest lakes, approximately 1,880 kilometers squared, completely within the United States. Similarly, Lake Victoria in Central Africa resulted from the upwrapping of the margins of the plateau in which it lies. Upwrapping can also occur in formerly glaciated regions where the release of pressure due to receding ice sheets may result in crustal rebound. This can be modified by glacial scouring activities, such as the case, for example, in the formation of the Laurentian Great Lakes. Tectonic lakes are occasionally formed in areas of local subsidence that resulted from earthquake activities. Many of these depressions are dry or only temporarily contain water, depending on the porosity of their underlying material, while others become permanent lakes, usually open with outlet drainage. So an example of an open lake that is tectonically driven is Lake Tahoe in California, Nevada. Lakes formed by volcanic activity. Catastrophic events associated with volcanic activity can generate lakes in several different ways. As volcanic materials are ejected upward and create a void, or as released magma cools and is distorted in various ways, depressions and cavities are created. If these depressions are undrained, they may contain a lake. Because of the basaltic nature of the underlying rocks and the often very small drainage basin areas, many lakes associated with volcanic activity contain low concentrations of nutrients and are relatively unproductive. Small crater lakes are occasionally found occupying cinder cones of quiescent volcanic peaks. Alternatively, crater lakes can occur in depressions formed by the violent ejection of magma or by the collapse of surface material where underlying magma has been ejected, termed Mars, and are generally small with diameters less than 2 kilometers. Mars are usually near circular in shape and can be extremely deep, greater than 100 meters, in relation to their small surface areas. Lakes formed by the subsidence of the roof of a partially emptied magmatic chamber are termed caldera lakes and can be somewhat larger than Mars, minimum diameter of about 5 kilometers. Among the most spectacular of lakes formed by the collapse of the center of a volcanic cone is Crater Lake in Oregon, with an area of 64 kilometers square and a depth of 594 meters. Caldera lakes can be very large and be modified in various ways. For example, Lake Toba in Indonesia, the largest volcanic lake in the world with an area of 1,130 kilometers square, occupies the caldera of a supervolcano and contains a resurgent dome that partially fills the original caldera. So some volcanic lakes originated from a combination of large-scale volcanic and tectonic processes. In some situations, caldera collapse occurred on such a large scale that extensive portion of the surrounding land subsided, in addition to the central portion of the volcano. Such subsidence usually takes place along pre-existing fault fractures. Some of the largest lakes associated with volcanic activity were formed in this manner, with many examples in equatorial Asia and New Zealand. Also, lava streams from volcanic activity can flow into a pre-existing river valley and form a dam behind which a lake can collect. Lakes formed by landslides. Sudden movement of large quantities of unconsolidated materials in the form of landslides in the floors of stream valleys can cause dams and create lakes, often of very large size. Such landslides dams may result from rockfalls, mud flows, ice slides, and even flows of large amounts of peat, but they are mostly found in glaciated mountains. The landslides are usually caused by abnormal meteorological events, such as excessive rains acting on unstable slopes. More spectacular slides are occasionally initiated by earthquake activity. Lakes formed behind landslide dams can be large in persistence, such as Sares Lake in Tajikistan, which was formed by an earthquake-induced landslide in 1911 and represents one of the deepest lakes in the world, with a maximum depth of 505 meters. More often, however, landslide lakes are transitory and exist only for a few weeks to several months. This short period is due to the fact that unless the slide is very massive, the unconsolidated dam is susceptible to rapid erosion by the effluent of the newly formed lake. Many disastrous floods have resulted from the rapid erosion of the dam material by the effluent which once started can quickly empty the accumulated lake. Lakes formed by river activity. The running waters of river possess considerable erosive power that may create lake depressions along their courses, from elevated land to large lakes or the sea. In the upper reaches of rivers, where gradients are steep, Excavation by water can produce rock depressions that may persist as lakes after the course of the river has been diverted. Plunge pool lakes, excavated at the foot of waterfalls, provide a rare but spectacular example of such destructive fluvial action. A combination of destructive erosional and obstructive depositional processes occurs as rivers flow down from gentle slopes to form lakes in the river floodplains. Many lakes are formed along large rivers when sediments of the main channel are deposited as levees across the mouth of tributary streams. In this way, the obstruction of the tributary flow continues until the side valley is flooded and a lateral lake is formed. Lateral lakes are frequently found in tributary valleys along major river systems on all continents, especially in the upper portion of the drainage. The reverse situation of fluvial dams holding lakes in the main river channel occasionally occurs as a result of deposition by a lateral tributary. If more sediments than the main channel can remove are deposited, the resulting lake may be permanent. As a river meanders within the irregularities of the topography, greater turbulence and erosion occur on the outer concave side of the river band, while deposition occurs on the inner convex side, where currents and turbulence are reduced. With time, continued erosion and concavity take place until the U-shaped meander of the river closes in upon itself. The main course of the river cuts a channel through the initial portion of the meander, and levee deposit eventually isolate the loop, referred to as an oxbow lake, from the river channel. The outer erosional side of oxbow lakes is usually deeper than the inner convex sides. Floodplain lakes, also known under various regional names such as Billabongs in Australia or Várzea and Ria lakes in Brazil, contain water throughout the year. When flooded, the floodplain of a river is usually covered continuously with water. As the river level recedes, water drains from the floodplains. Lakes persist in depressions perched above the river or in deep depressions that remain connected with the river. Where rivers enter the relatively quiescent waters of a lake or the sea, sedimentation results in the formation of deltas, often of very large size. Deltaic lakes are formed in the delta of large major rivers of the world. As the river velocity becomes reduced and sediments are deposited, the water tends to float around the sediments in a U-shaped pattern where they open and extend up seawards. As alluvial deposition extends further seawards, it eventually encloses and isolates inward depressions to form shallow lakes, often of large size. Subject to the influence of tides and other water movements of the sea, these deltaic lakes often receive salt water, making them brackish. So before we jump into the section F here with lakes formed by shoreline activity, let's look at this figure. So this is figure 4-16, different lake types created by river activity. So this is the upper part of the watershed, and as the text was mentioning, we have like a, let's say, a waterfall here. And the erosion of that waterfall is creating what is called a plunge pool lake. And then sometime we have a lateral lake that is created like along a river, like in the upper part of a watershed as well. So this is a river, and somehow there's a constriction here that prevents the water to flow at the rate that the river would allow. And so therefore there's a lake that is created. Then we have in the lower part of the watershed, we have floodplain lakes. So this is the floodplain pattern, and this is the riparian zone. And then so there's a floodplain lake that is created here. And then this is an oxbow lake, where a meander pretty much isolated itself and created this sort of U-shaped lake. And then we have these deltaic lake. This is the delta of the river that reaches ultimately the sea or an ocean. And then we have those deltaic lakes that are just lakes that are created within the floodplain of the river and its depositional environment. F. Lakes formed by shoreline activity. When the coastline of a large body of water, such as the sea or a large lake, possesses some irregularity or an indentation, the potential exists for the formation of a bar across the depression to form a lagoon or coastal lake. A longshore current flowing along the shoreline and carrying sediment will, on encountering a bay, deposit the material in the form of a bar or spit across the mouth of the indentation. Often the spit can eventually separate from the bay from the sea or from the large lake to form a coastal lake. Marine coastal lakes commonly result from sandbar formation across the mouth of old estuaries that have been inundated by rising water levels or slight subsidence of the land. Often, river discharge and tidal currents are sufficient to prevent complete separation of the lake from the sea. The result is an alternation between fresh and brackish water in the lake, and the salinity depends upon the ratio of freshwater inputs and saltwater intrusions. Other coastal lakes are completely separated from the sea. Numerous coastal lakes are also found inland, adjacent to large lakes. The formation of these water bodies occurs in an analogous fashion by the deposition of bars and spits across bays and river valleys. Lakes formed by solution. Lake depressions can be created in any area where deposits of soluble rocks are slowly dissolved by percolating water. Although many rock formations are readily soluble, salts such as sodium chloride, NaCl, calcium sulfate, CaCSO4, and ferric and aluminum hydroxide, most solution lakes are formed in depressions resulting from the solution of limestone, calcium carbonate, by slightly acidic water containing carbon dioxide. Solution lakes in the form of karst outcropping lakes are thus common in many limestone regions of the world, such as the karst region around the Adriatic Sea, especially in the former Yugoslavia, Southeast Europe, the Alps of Central Europe, Central and Southern China, and various regions in North and Central America, including Florida and the Mexican Yucatan Peninsula. Solution lakes often occur in very circular and conically shaped sinks called dolines, which develop from the solution and gradual erosion of the soluble rock stratum. Percolating surface or groundwater dissolves limestone most readily at the joints and joints of fault fracture through which it drains. Adjacent dolines may eventually fuse to form compound depressions that are more irregular in conformity. Alternatively, the dissolution of limestone frequently occurs in large subterranean caves. Continued erosion of the superstructure by groundwater results in its weakening to the point where the roof collapses, which form a reasonably regular conical doline. The level of water in a solution lake is often highly variable. Usually the depressions are sufficiently deep to extend well into the groundwater table and permanently contain water. Other depressions that just reach the water table can undergo fluctuations in water level in response to seasonal and long-term variations in groundwater supply. Lakes formed by wind activity. Wind action operates in arid regions to create lakes by deflation. For example, wind erosion of loose material, which over long time scale can scoop out hollows or blowouts, or by redistribution of sand to block existing river valleys, thus forming aeolian or dune lakes. Such lakes depression may be solely or partially the result of wind action, and the water they contain is often temporary and depend upon fluctuation in climate. Different types of dune lakes can be found in inland desert regions of the world, as well as in coastal areas. For example, organic additions from vegetation can assist in creating impervious, organically bound sand rock in dune depression, which may fill with surface water. In contrast, deflation depressions that are permeable to water can form lakes when they extend below an extensive groundwater table. All of these lakes are extremely transitory. Deflation lakes are also found where material is moved and eroded from horizontal strata of rocks or clay by wind activity, permitting the formation of large pans on nearly level areas, often called playas. The center of the pan then fills with water during rainy season or wet periods, creating an aeolian lake that becomes increasingly saline with evaporation, followed by desiccation during opposing season or dry periods. These ephemeral lakes are common in large portions of Australia, Southern Africa, endorheic region of Asia and South America, and the plains and arid region of the United States. So there's like a famous playa in northern Nevada called the black rock playa where Burning Man is actually held, and this is a good example of an aeolian-based lake. Before we jump into the next section, let's look at some of the pictures of some of these lakes here. So this is a karst outcropping lake, and as mentioned in the text, it's very common in the former Yugoslavia region. There's some in Slovenia, for example. This is a Dorning lake, so it kind of looks like a cone. It's like a dissolution-based lake. This is an aeolian lake, like a windborne lake. This is a meteorite lake. This is a beaver dam lake, so there's a beaver dam here, created a lake behind it. And this is a reservoir, which is an anthropogenically driven lake, man-made. Lakes formed by meteorites as a rare form of exogenic origin. Meteorite lakes or impact crater lakes are water accumulations inside a depression caused by the drastic impact of a meteorite. Meteorite lakes occurs on all continents and can be very deep and old. As a special form, annular lakes are impact crater lakes shaped like a ring. One of the largest examples is Lake Manicouagan in Canada, with a surface area of 1,942 kilometers squared, albeit increased by damming. Maximum depth is 350 meters. Estimated age of the crater is greater than 200 million years, which constitutes an annular lake with a diameter about 70 kilometers across, surrounding an inner island plateau that was formed by the post-impact uplift. So this is the lake that we are talking about right here. And this is the plateau that we're talking about. You know, the text says the meteorite lake is Manicouagan Lake in Canada. Lakes and of organic origin. The array of lakes created by the damming action of plant growth and associated detritus is not fully understood. It is known, however, that the growth of emergent and floating aquatic plants can be sufficient profuse to dam the outlet of shallow depressions and alter the drainage patterns of lakes, particularly in floodplains of tropical river systems. Such alteration of drainage by plant growth are common in dystrophic lakes, which contain large amount of humic, undecomposed organic matter. Also, the photosynthetic activities of attached cyanobacteria and other algae, as well as aquatic macrophytes, can induce massive precipitation of calcium carbonate from calcareous waters. In time, these deposits can form barriers and isolate water bodies of water from stream systems. As an iconic lake-forming animal species, native to the temperate northern hemisphere, the beaver is particularly effective in constructing dams across river valleys to impound water into lakes. While most of these structures are temporary, some become permanent by means of sediment deposited against the dam. For example, the widespread North American beaver, Castor canadensis, has created numerous large, long-lived lakes throughout the boreal and temperate ecoregion of Canada. And then lastly, lakes of anthropogenic origin. Humans have created artificial lakes by damming streams for at least 4,000 years. The pace and scale of damming, however, increased dramatically in the mid-20th century. Thousands of large dams have been built to create anthropogenic reservoirs to store water for irrigation, hydroelectricity, and other purposes. Some of them, such as Lake Volta in Ghana, Lake Nasser in Egypt, Lake Kariba in Zimbabwe and Zambia, Smallwood Reservoir in Canada, Sobrahindo Dinho Reservoir in Brazil, or Bratska Reservoir in Russia, are comparable in size to the world's largest natural lakes. Small shallow reservoirs in the form of farm ponds and moderately sized inundation outnumber the large one by millions. The shallow morphometry of these reservoirs can create extensive areas where macrophytic vegetation thrives, and such plant life can radically alter the productivity of the lake system. Moreover, as these ponds are most commonly associated with agricultural landscapes, small reservoirs generally receive high nutrient inputs in relation to their volume, which further increases their productive capacity. For more information on reservoirs, see section 4-6 below.